Good morning, dear children. Today we will have a quick glance on the chapter Periodic Classification and then Properties. And once we have a glance at the chapter, we will understand what type of questions can be asked for your examination. In the sense, we will understand, we will create some of the questions, and we will also take some of the questions which have been already asked in your previous examination. Before I start with the exam point of view, let me tell you some of the important points which we should remember with respect to this chapter. So I welcome all of you for the discussion of the chapter Periodic Classification. So why exactly the need of the classification is done? That all those things we have discussed already in the class. Need of classification is mainly due to arranging all the elements in a systematic order, and study of them will become very easy. That was the cause or need for the classification of elements. As you know, I have a periodic table here. Periodic table, it is given us with a complete arrangement of the elements. Illi ella elements anna already arrange ಮಾಡಿ ಕೊಟ್ಟಿದ್ದಾರೆ. Okay? So when you consider the periodic table, I would like to tell you that there are mainly of 118 elements have been found till today. Okay? And all the 118 elements have been arranged in a systematic order. That order of arrangement is starts from S block, P block, D block and F block. Before we understand the blocks, how many blocks have been classified, we need to understand what are the groups and what are the parents. Before understanding this part, we have done the introduction part with the Daubermayer triads. We have discussed Mendeleev's periodic table. We have seen the definition. We have seen modern periodic law. All those questions can also be asked in examination. As we have done all those things in detail, I am going through the periodic table. So you can see here, this is considered to be a first group. This is considered to be a first group. Do remember, dear students, there are mainly 18 groups. There are mainly 18 groups and 7 periods are present in the periodic table. There are 18 groups and 7 periods are present in the periodic table. So if you are considering this is as a first group. So what are the elements present in the first group? The elements are hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So these are considered as group 1 elements. Likewise, I have group 2, second group. This is third group, 4th, 5th and so on. I have up to 12 here. This is 12th group. Then I have 13th group, 14th group, 15th, 16th, 17th and totally I have last group, that is 18th group. So whatever the elements are arranged in a vertical fashion, these elements are arranged in a vertical fashion are all called as groups. ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ನಾವು ಈ ರೀತಿ ವರ್ಟಿಕಲಿ ಅರೇಂಜ್ ಮಾಡ್ತೀವಲ್ಲ ಅವಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು ಗ್ರೂಪ್ಸ್ ಅಂತ ಕರಿತೀವಿ. And there are certain elements can also be classified in the horizontal rows like this from left side to right side. In the form of rows they have been arranged. They are called as periods. There are 7 periods in the periodic table and 18 groups are present in the periodic table. So I could tell here that this is the first period, second period, third, 4th, 5th, 6th and this is 7th period. So when you consider these are the groups and periods, I must say you regarding blocks. So when you consider this group 1 and this group 2, these together are referred as S block. They are called as S block elements. Group 1, group 2 together comprised, they are called as S block elements. Then I have next one from boron. You can see here this is 13th group. From 13th group to 18th group, whatever the periods and groups are present, they are called as P block elements. And in between I have certain elements present from group 3 to group 12. They all are called as D block elements. I have group 1 and 2, together it is S block. I have from 13 to 18 group, these all are considered as D block. In between I have from 3 to 12, all these elements, these are called as D block elements. And there are certain two rows are also present at the bottom of the periodic table. They have separated from this whole periodic table. They all are considered as F block elements. Why these are placed at the bottom? Because all these elements are showing property as that of same kind. F block elements, they are called is mainly because they will be showing property of same kind, which is slightly different from the D. Which is slightly different from the D block elements property. So they are together placed at the bottom. So this is all about general introduction of the periodic table. And the same we have used and we have already discussed. And now I could explain you all the things, the general trends, what are the important points we are supposed to understand with respect to periodic table, that I will be telling you. For time being, let me remove this periodic table. Let's directly consider the questions. Before I start with the question session, I would like to tell you these all are considered as group 1 elements: hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. And here I have group 2 elements. They are beryllium, magnesium, calcium, strontium, barium and radium. These are group 2 elements. Likewise, I have group 13 elements. These are referred as boron, aluminium, gallium, indium, halium. Then group 14 elements. This is also coming under the category P. So carbon, silicon, germanium, tin, lead. These will be considered as group 14 elements. Likewise, I have here group 15 elements: nitrogen, phosphorus, arsenic, antimony and bismuth. Then I have group 16 elements: oxygen, sulfur, selenium, tellurium. Then I have polonium. 17th group, most familiar group, which is called as halogen family, and the elements present here are fluorine, bromine, iodine, astatine. So these are the elements present in halogens. And last one, which you've been reading about this one since 9th standard, these are referred as inert gases or group 18 elements. They are also called as noble gases. Why the name so and all, everything we will discuss further. Now I can say the elements present in 18 group are helium, neon, argon, krypton, xenon and radon. So why I am particularly telling the names of the elements is here because we will be understanding the properties of all these elements by considering the respective groups. We need to understand the properties of all these groups in detail when we start with the question and answer session. Right? So this is all about the periodic table. There are in total 7 periods, 18 groups, and there are mainly 4 blocks are present: S block, P block, D block and F block. And even I have told you what are the elements so and so present here. So having idea regarding this one, we move to next now. So welcome back dear students. We have some of the questions. I have taken some of the questions from the model question paper. So first question I have written here. Name 2 elements of modern periodic table which have completely filled outermost shell. Which have completely filled outermost shell. As we have already seen in the periodic table, we can say that S block elements are representative elements and P block elements are also referred as representative elements. So when you consider particularly group 18 elements, as we have discussed them regarding, they are called as noble gases. They are called as noble gases. They are also called as inert gases. They are also called as inert gases. If they are asking you the question for 1 marks, you have to write all noble gases or inert gases have completely filled outermost shell. What does it exactly indicate? Let us consider one of the examples from any of the noble gas group. So when you consider particularly neon, neon symbol is Ne. Its atomic number is 10. Its atomic number is 10. So we all know how to write the electronic configuration. Electronic configuration writing part we have already discussed. Neon, how you are going to write? You will be taking 2 electrons in S subshell, that is you can call it as K subshell. Then we have next subshell present over here. Next subshell is considered to be L subshell, or we can say P block. It has capacity of totally 6 electrons. Okay. Even I have probability of writing electronic configuration as 1s2. Okay. Then I will be writing as 2s2. Fine. Once we write 1s2, 2s2, we can see that there are 4 electrons have been accommodated. 4 electrons have been accommodated. How we arrange all the 4 electrons? See, I can write 2 electrons in 1s. I can write second pair of electrons in 2s2. In total, 4 electrons are completed. Still, how many left? 10 minus 4, 6 electrons left. So all those 6 electrons can be written in the P subshell, and the configuration will be 1s2, 2s2, it will become 2p6. If you are filling all the rest 6 electrons in P subshell, it would be 1, 2, 3, 4, 5, 6. It will be written in this fashion. So you can see here no subshell, any of the subshell left unfilled. ಇಲ್ಲಿ ಏನಾಗ್ತದ S ಕೂಡ ಫಿಲ್ ಆಗಿದೆ. S capacity, K shell capacity we know it is 2. It is completely filled. Then we have 2s2, it is also completely filled. Then I have 2p6, it is also completely filled. No subshell is left. That indicates that noble gases have completely filled outermost shell in them. So any of the noble gas like neon or argon or krypton, you can be writing them as an example, and they all are considered as stable. They shows stable electronic configuration. Stable electronic configuration in the sense they do not react easily with any element. They do not need any electron. They don't give any electron for the bonding purpose. So these are referred as stable configurations. Fine. So all the noble gases will be considered as completely filled outermost shell they possesses. Fine. I think this is understood to you all. This is important and is has been asked in your model question paper for 1 mark. It is being asked in model question paper for 1 mark. So what we are doing here, 10 standard revision we are doing with respect to previous question papers and model question papers. So you know there is a second question is being asked, define Mendeleev's periodicity. How we can define Mendeleev's periodicity? Mendeleev's periodicity mainly concentrated on the atomic mass. So periodic functions will be arranged with respect to atomic mass. So when you consider particular definition, we have to write the definition which is being given in the text. Like that only we have to write. So we can write that the properties of the elements are periodic functions of their atomic mass. Properties of elements. The properties of elements are periodic functions of their atomic mass. Periodic are periodic functions. Periodic functions of atomic mass. So this is definition can be asked for 1 to 2 marks like that, like this you have to write. So this is all about what we have discussed with the Mendeleev's periodic table. So there are certain drawbacks we have seen in the Mendeleev's periodic table. Some of the isotopes couldn't placed, and some of the atomic masses were not in an increasing order. In order to come or overcome all the drawbacks, new scientist Henry Moseley has introduced the modern periodic law. What does modern periodic law tells us? There is an simply some of the modifications are done with respect to Mendeleev's periodic table. They are called as the properties of elements. Properties of elements. I have to write here. Properties of elements are periodic functions of their atomic number. Atomic number concept has been introduced. So I could write here the properties of elements. Properties of elements are periodic functions of atomic number. Periodic functions of atomic number. This is how we will be writing the answer for the question modern periodic law, which was introduced by scientist Henry Moseley. So these are considered to be generally 1 mark questions. If generally they are asking for the definitions or simply in one step or one statement they are asking, they can be asked for 1 mark. So this is how we supposed to answer for the questions on the basis of the marks have been asked. So with these simple questions we will have still more questions, and please all the students write these aside in a paper, and with your examination, when you are nearing with the examination, have a quick glance on these questions. Okay, write down properly. Welcome back, dear students. I have one of the question here. Name any of the element which has only one electron in its valence shell. Only one electron in its valence shell. What is the question? Name the element. Name the element which has only one electron in its valence shell. This is my question. How am I supposed to answer for this question? I have to understand. So as I told you, there are mainly 18 groups are present. We will have discussion with respect to group 1. So let us consider group 1 elements. Group 1 elements. Can you tell me, pause the video and can you tell me what are the group 1 elements? Yes, very good. It starts from hydrogen, lithium, sodium, potassium, rubidium and so on. So maximum of these elements are enough for you. So we know that hydrogen will be placed in alkali metals, that is in group 1, as well it will be placed in group 17. So we exclusively do not consider hydrogen belongs to group 1 itself. Let's consider this as an exception. Let's speak about lithium. We know that elements atomic number up to 30. I have been asking you to memorize the elements up to atomic 30 and their symbol, their name and their atomic number. You have to memorize. So lithium possesses atomic number. Let me consider this side. It is called as atomic number. So lithium possesses atomic number hydrogen, helium. Next element will be lithium. So when you write the electronic configuration for lithium, if you are writing, it will be 1s2, 2s1. It has left with 1 electron. Similarly, if you are considering sodium, it is having atomic number 11. I would be writing 1s2, 2s2, 1s2, 2s2, 1s2 is completed, 2s2 is completed. I will be writing 2a1 like this also you can write. So 1s2, 2s2, 2p6 and we will be having 3s1. 2p6. So in total from here it will be 10 electrons and 1 electron is left in s sub shell. So I can write an answer for this question. All group 1 elements, they will be showing 2s1, 3s1. Next with this element will be showing you 4s1, 5s1 and so on. Any one element from the first group will be the answer for this question because they have 1 electron left. As a 1 electron which is considered as valence shell electron. What is the question you can see here? Name the element which has only 1 electron in its valence shell. I could write all the elements of group 1 possesses 1 valence shell electron in their valence shell. As well, I would exclusively write the example of potassium, sodium or lithium and so on. Any one of the element if you write, then also answer is correct. If you write all the elements of group 1 will shows 1 valence electron in their valence shell, that will also be correct. So like this we can find out the number of electrons which are present in their valence shell just by writing the electronic configuration. In order to write the electronic configuration properly, we need to understand the atomic number of particular element. Once we are very thorough with the atomic number, we could easily write the electronic configuration and we could easily identify the number of valence electrons present in that particular element. So in common we can say that all group 1 elements show 1 oxidation state. I can say that plus 1 oxidation state. They can easily lose 1 electron from their valence shell to attain the noble electronic configuration or noble gas configuration. All the elements will be trying to attain the nearest noble gas configuration. So I can say group 1 will be the example for this question which has 1 valence shell electron. By seeing this one, can you tell me what will be the number of electrons are considered as valence shell electrons for group 2? Have you all answered for the question? What is the second question? What are number of valence electrons? What are number of valence shell electrons present in group 2? Or even they may ask you, name the elements which shows 2 valence electrons in their outermost shell. Like that also they will ask you. So what are group 1 elements I told you? By seeing the periodic table we have already discussed. Group 1 elements, group 2 elements also. So group 2 elements will be starting from beryllium. So lastly we will be having the radium. So beryllium, magnesium, calcium, strontium, palladium, radium. These all are considered as group 2 elements. And as group 1 elements shows common plus 1 oxidation state. ಅಂದರೆ ಪ್ಲಸ್ 1 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅರ್ಥ ಏನು? ಒಂದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಈಸಿಯಾಗಿ ಲೂಸ್ ಮಾಡ್ಬೋದು. ಒಂದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಈಸಿಯಾಗಿ ಲೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋದ್ರ ಮೂಲಕ ನಾವು ನೋಬೆಲ್ ಗ್ಯಾಸನ್ನು ಆ ಕಾನ್ಫಿಗರೇಷನನ್ನು ಅಟೈನ್ ಮಾಡ್ತವೆ. ನೋಬೆಲ್ ಗ್ಯಾಸ್ ಥರ ಆಗ್ತವೆ. ಅಲ್ಲಿ ಸ್ಟೆಬಿಲಿಟಿ ಏನಾಗುತ್ತೆ, ಎಲಿಮೆಂಟ್ಸಿಂದು ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ವಾಟ್ ಐ ಹ್ಯಾವ್ ಹಿಯರ್, beryllium, magnesium, calcium, these all are considered as group 2 elements. So group 2 elements in we consider ಮಾಡಿದ್ರೆ what is the atomic number for beryllium? Hydrogen, helium, lithium, beryllium. Beryllium atomic number is 4. How you will be writing the electronic configuration? So it will be written as 1s2 and 2s2. So here in the outermost shell 2 electrons are lying. And similarly, when you consider the magnesium, we know it is atomic number 1. Right? So when you write the electronic configuration, it will be 1s2, 2s2, 2p6, and I have 3s2. One more electron is increasing from the group 1. Group 1 only 3s1 ಇರ್ತಿತ್ತು, 2s1 ಇರ್ತಿತ್ತು. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, group 2 ಒಳಗಡೆ 2 electrons are lying in the outermost shell. So what will be the answer for the question? There are 2 valence electrons. There are 2 valence shell electrons are present. Or I can say that group 2 elements show. Group 2 elements show 2 as a valence electrons. 2 as a valence electrons in their outermost shell. In their outermost shell. So this is how you will be writing the answer for the question they ask. So one more point, let me explain with this itself. Whenever you go down the group, what will happen? Tendency of losing these electrons, outermost shell electrons, losing tendency increases. When we go down the group, losing of these outermost electrons, that tendency what happens, increases. ಯಾವಾಗ ಈ ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡುವಂತ ಟೆಂಡೆನ್ಸಿ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೆ, ಡೌನ್ ದ ಗ್ರೂಪ್ ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್, ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇನ್ಕ್ರೀಸಸ್. ಡೌನ್ ದ ಗ್ರೂಪ್ metallic character increases. So these all are considered as good metals. Group 1 ಅಂದ್ರೆ ಯಾವಾಗ ನೋಡಿದ್ವಿ ನಾವು, hydrogen, lithium, sodium and so on. All them are considered as alkali metals. Okay, ನಾವು ಕರೀತೀವಿ alkali metals ಅಂತ ಕರೀತೀವಿ. ಇವು group 2 elements ಏನಂತ ಕರೀತೀವಿ ನಾವು, they all are considered as alkaline earth metals. Alkaline earth metals because they found in earth crust and they are basic in nature. Alkaline is denoted they are very much basic in nature and they will be found at the earth crust. So they all are considered as alkaline earth metals. Fine. So all alkali metals, they are also basic in nature. Group 1 metals are called as, they are alkali metals. Remember, when you go down the road, metallic character always increases. This is the important point. And when you go down the road, atomic size increases. Atomic size increases. Why does this so happens? We will explain. We will understand the things by taking the questions. Few more questions we will consider and we will understand what should be the answer must be written for the respective questions. Students, neatly copy each and everything. We will consider next questions.